And our last special segment in a triangle is called an altitude. Now, altitudes I like because altitude, when I think of it, reminds me of height. The altitude that you are when you're climbing a mountain. And so you've probably already seen an altitude before when you found the area of a triangle, because you always did base times height of a triangle. And so the altitude is the distance from one vertex to another side. And so when I mean distance, we need to find that perpendicularly. So it is the perpendicular segment from a side, or an extension of it, because in this picture, notice how we have to draw an extension of this side SR to be able to make it perpendicular. So from the side to the vertex perpendicularly. Sometimes you need to draw an extension of it so that you can have the altitude. So sometimes the altitude is outside the triangle, and sometimes an altitude in a right triangle would be equal to. Altitude is a side. So altitude and the side are the same. Now, if you're going to draw an altitude for a triangle, you have to make it perpendicular. And so I drew two of them here just to simplify the picture a little bit, and if we have two of them, the third one's definitely going to intersect as well. And so I put the needle here and I made this arc. And so I came up with these 2 points. And from those 2 points, I made my perpendicular bisector. So I did that up there, and then I made this arc right here, and they intersected right there. I did the same thing. I put the needle down here, and I made this really wide arc here, and it intersected right here and right here. And then that became the endpoints for my segment that I made the perpendicular bisector for. So I put the needle right there, made a circle, put the needle right here, made a circle, and right here intersected with my vertex. And so those are altitudes, meaning perpendicular from the side to the vertex. All of the altitudes intersect, or they're concurrent, that fancy word we introduced, and their point of concurrency is called the Ortho Center, like the orthodontist, but the Ortho Center. Now, all of the other ones had special relationships. This one, it's just, hey, all of the altitudes meet at the same spot. Not quite as special. And so we have the point of concurrency of altitudes. We've got an altitude and an altitude and an altitude. They all meet together. They are concurrent. Again, it's called the Ortho Center. Now, trying to remember all of these and when we know what we have. And so, if we have angle KMS congruent to angle LMS, that must be that this is an angle bisector. If we know that KS is congruent to SL, well then we know that this is bisecting it, but it's not necessarily perpendicular, so I don't know it's a perpendicular bisector, so it's called, this is the midpoint to the vertex, that's called the median. If I know that these are perpendicular, then I know that it's an altitude. Again, when we see perpendicular, we automatically want to say perpendicular bisector, but it's not necessarily, because we don't know that it's perpendicular. But if we know it's perpendicular and its KS is congruent to SL, we know this perpendicular bisector. And so notice how all three of these are very, very similar. And so we have the median, which is vertex to midpoint, and we have the altitude, which is the vertex is perpendicular, and then when they're both perpendicular and the midpoint, we have the perpendicular bisector. Sometimes they are all one and the same. For example, if your altitude is cutting it in half, the median and the altitude are going to be the same, because if it goes through the vertex up there. And lastly, we have a proof. So if ABC is isosceles, meaning this side is the same as that. And it's also a median. And a median connects vertex to midpoint, and so I know that this is congruent to this. Prove that it's also an altitude. So prove that it's perpendicular, essentially. So I've got, it's isosceles. So that tells me that those two sides are the same. That's what isosceles means. Then I know it's the median, and what does the median tell me? Well, median tells me that it cuts it in half, that it's also the bisector. And so there's a couple different ways you could go with it. I chose to say, well, it must be bisecting AC then, so that I know it's the bisector. What makes it extra special is because these B, because B is equidistant from A and from C, we know it's got to be on the perpendicular bisector because B is the same distance. And that was the perpendicular bisector converse because we knew those two things were equidistant. And then finally, because it's perpendicular bisector, it's got to be an altitude because it's perpendicular to the side through the vertex. And that's pretty much it. So median tells us that it was cut in half, and then because it was equidistant, it was not only cutting in half, it was also perpendicular. And so we also knew it was an altitude. And so from there, again, we knew it was all three of those things. There you have it. The altitudes of a triangle.